Flowcharting isn't the only way to visualize algorithms. Many times, programmers use pseudocode to lay out their algorithms and examine them to make sure they're going to work. Pseudocode is such an important feature of program development that the College Board actually developed their own system of pseudocode, and it will be very important for you to understand this system for the test. So the AP exam this year's was 74 multiple choice questions. Most of them have one correct choice. There's a small section of them that have two correct choices. And all of them are going to test your understanding of programming, algorithms, algorithmic concepts using pseudocode. It's an informal method of writing algorithmic instructions that doesn't necessarily have a particular set of grammar rules or syntax or anything like that. But for the College Board, they need a way to make sure that everybody, no matter which programming language they're using, understands certain things. And so they developed a particular way that they show these concepts. You may have heard of other words that start with pseudo, like a pseudonym would be a false name. So pseudo means that it's false. So is it really false code? Well, not necessarily. It's an informal way of writing out the algorithm, the instructions. It doesn't have a particular set of grammar rules. It doesn't have syntax, but all the same, it is still a really nice, efficient way to show your algorithm. So programmers all have different ways that they write pseudocode. There is no one standard universal form that everybody would use, but most people, individuals or groups, organizations that need to develop and communicate high-level algorithms will often agree amongst themselves on a particular way of writing algorithms or of setting up notational conventions that they will all use. And so the College Board has done the same thing. They have developed an AP exam version of pseudocode that they stick to throughout the exam, throughout the course, and we are going to get you familiar with that over the rest of the course so that you can prepare. So with each logical concept that is introduced, we want to understand it both in our coding language, whichever that coding language might be, Scratch or processing or anything else, but also in pseudocode. So why this pseudocode? Why do we need to have it, and why would we bother writing it if it's not actual code? Well, to be concise. We can get a little wordy in our writing and in our speech, some people more than others. And this is what we've been doing to communicate algorithms. It has a very clear and, for the most part, intuitive structure that has hopefully been easy for you to read and follow and understand. But even with that, it can tend to be a bit wordy. So here's an example of a lack of precision. We might start to abbreviate our wording because we're tired of writing the same word over and over again, so we just develop some sort of abbreviation for it. We might start dropping the little conjunctions, little words that aren't essential. We might start getting rid of them. So anytime you abbreviate text or you leave out some words, you do run the risk of leaving out some important information in your efforts to try and make yourself more concise. When you're talking about algorithms in general, we're really more interested in being able to describe the solutions at a very high conceptual level or a high level of abstraction without needing to get into the specifics of a particular programming language at all. And that's where pseudocode comes into play. So what does this pseudocode look like? Well, let's take a look at the actual AP pseudocode reference guide that College Board gives to you. All right, so what I've got open here is the AP Computer Science Principles Exam Reference Sheet. This is published by the College Board. It is available online. You can access it. You will probably receive a hard copy of this from your teacher when you are doing exam prep and things like that. When you take the AP exam, this is included in your booklet. If you've never taken an AP exam before, when you take the test, it is pencil paper, and you receive a booklet of questions. And this reference sheet will be at the beginning of that booklet. So it'll be a little bit smaller than this. It won't be this 8.5 by 11 size PDF, but you will absolutely have access to this when you take the exam. Now, let's talk a little bit about what this is for. and how it might be useful to you in practice tests and on the exam itself. So, as you hopefully know by now, we're using Scratch and we'll use processing a little bit later, but this actual course, according to the College Board, doesn't require that students learn one particular programming language. And because of that, they need to have a way that isn't language specific to refer to programming structures and things like that. And so what they provide for you is this sheet right here. We're going to talk about a few sections. We're not going to talk about every single section because you haven't covered them yet, but it's important for you to start getting used to this sheet and the information that it contains. So the first section shows you the pseudocode that you might expect to see on the exam when they want to know if you understand about assigning a value to a variable. They might show you something like this right here. They will give you this rounded rectangle, and what they want you to understand is that A is a variable and that you are going to assign it a value based on whatever expression is. This expression might say, it might say another variable, it might say the letter B, it might say A plus 1 or A minus 1. So there could be, some sort of other mathematical expression, or it could be the sum of two other values, B plus C or something like that. So we don't know what the expression is, but we do know that this arrow right here means that whatever the expression is, whatever value it has, that is being assigned to our variable A. That's a pretty simple one, but you will see a lot of that. So we can assign a value. We also know, you've worked in Scratch enough to know that we can display the value of a variable or an expression. And so that's what this one here does. We've got the block code that shows us the word display, all caps, meaning that's the command. And then it's got this rectangle, and expression is in there. And again, expression, that could be just about anything. It could be the variable itself, it could be a string, it could be a mathematical expression like A plus B or something like that. But whatever the value it has, that is what it will display. And just a little side note, that whatever is displayed will actually be followed by a space. I don't know if you remember using the join commands, the concatenation, but sometimes that is important, and the space is not always added for you. But it is important to note that in AP style pseudocode, you can assume that there will be a space after the value. All right, and then we've talked about input plenty, and the block that you would see in that particular case is just this word right here, input, in all caps. And that just means that we're accepting a value from the user and returning it. All right, let's talk a little bit about this next section. These are some things you might see when there are some operators or numeric procedures involved. And first off, we've got our typical 4 operations: add, subtract, multiply, and divide right here. And just a quick thing, I know many of you might be accustomed to seeing this one right here. This is multiplication. A lot of times we use an X for multiplication. However, when you are typing code, you can't use the letter X to indicate a mathematical operation. And so for whatever reason, it was just decided and is now very commonly used is this asterisk. And this asterisk indicates multiplication. If you've ever had to do any Excel formulas or formulas on a spreadsheet, you'll know that that's how that works. And then also, we don't have this little thing right here. We don't have the divided by sign. Instead, it's a fraction bar. Okay, or a slash. And we all know that fractions are division problems. And so again, the divided by sign doesn't work well. That's a special character. It's not easy to type on a keyboard without help. And so it just needs to be something simple. All right, and so those are our 4 basic operations as you might see them. Here's one, we haven't used this yet. This will be something that we talk about later. If you have not heard of modular arithmetic or the modulus operator or modulo, A mod B, if you were to see that on the exam, it actually evaluates to the remainder of a division problem. And the example that they give you there is, for example, 17 mod 5 evaluates to 2. And the reason for that is that if you take 17 and you divide it by 5, you will find out that 5 can go 3 times into 17, but that's only 15, and I've got a remainder of 2, and there's nothing left to be done with the 2 unless you want to carry it out to a decimal. A time when this is actually very useful, a lot of times your computer is tracking time in a 24-hour format. And when you try to pull the current time into your program, you might pull the current time as 1,400 hours or 1,600 hours or something like that. And that's not the way that we're accustomed to seeing it. So what we do is we take that time, whatever the current hours are, and we say, I want to do that mod 12. And 16 mod 12, we know 12 only goes in one time, but it has a remainder of 4. And so that would yield 4. And that means 4 o'clock. So that's just a little side note on the use of the modulo operator, but that is something that you may see. And that's how it would look on the AP exam. And we've already talked about random. We've talked about A and B would be the same as in Scratch when we say we want a random number between 1 and 10. So the first value is the minimum, the second value is the maximum, and what's important to note is that it says that random 1 to 3 could evaluate to 1, 2, or 3. Sometimes in some programming languages, the random operator is not inclusive. You might specify the minimum number and then it would not include that as part of what it could choose. And so it is important to notice that that is inclusive. All right, we will come back to these. These are the way that you might see Booleans. You are more accustomed to seeing Booleans as a hexagon. This shape, you might remember these. That is a terrible hexagon, sorry about that, but you might remember that shape from Scratch. So we'll come back to that a little bit later.